Alright, this is the latest version of the TerraXMapper imaging software. I'm just going to give you a little tutorial here. It's super easy. In the beginning it walks you through, so it'll highlight what you need to do. So follow this little red box. So you load the file and you go to your wherever you have your survey files saved. It could be on the SV card or the SD card or on your tablet. So we're just going to click one here. Depending on the size of the file, it can take a little bit to load up. This particular survey was maybe like half of a football field, so decent size, but not too big. All right, so then it goes highlight red. It wants you to select your coordinates, so always longitude first, then latitude. Then we're going to select which mag sensor you want. There's a whole suite in here, so you can have the X, Y, Z, total mag, or the gradient. Um, each one of these will give you a different image, and we can look at it, and they can each have their strengths and weaknesses. Total mag is a combination of all these three, basically averaged. You're going to want to use most of the time total mag or gradient. Gradient is the best. That is the difference between the total mag of the top sensor and total mag of the bottom sensor. So this is typically the one you want to use. So for this, we'll use gradient. Hit generate plots. This can take just a little bit. Okay, so it's going to pop up with two images. On the left is your interpolated image. On the right is your raw data. So what we use the raw data for, this is your actual path that you walk the survey. If you notice on the bottom left of the window, you can see latitude, longitude, and your mag point, so you can go in each individual point and kind of see what the mag field was doing there. What's important on this is, so if you couldn't get around, so say there was a big tree here or something, um, when you see over here, it just shows you there's no data. That way you don't get false anomalies. Some of the softwares will just fill everything out just to make a pretty picture, but you can end up with a false anomaly. But it's also nice to be able to fill that out if you want to. So like right here, you can see that these are probably connected. So we can go up to this blanking. Standard is 3 where we leave it. We can up this to say 6. We'll hit generate plots again. And what it'll do is it uses the software to kind of guess, what's going on. So you can see there it did complete these anomalies. And it can be helpful, so you say you got an underground wall or whatever, and you missed a spot or something, you can do that, and it'll help complete your map, make sure your image is nicer. So for this, I'm going to leave it back on 3. All right, there's several grid styles. This is hill shaded. You've got contours in there. We can adjust the color ranges. This kind of does the mid. It will amplify or lower the mid, so it kind of helps you identify anomalies. So you can increase the mids if you want. Also the highs and lows. This one will get you kind of focuses more on the highs, or you can get it focused on the lows. So we can reset that. Render or standard and enhanced. Standard's going to give you it'll load up a little quicker, but doesn't really save much time, so I just typically leave it on enhanced. Then you have color map. You've got a bunch of different colors that you can use. You always hit regenerate. And there's ones like this. It'll really amplify your anomalies. So this is kind of user's choice. default comes up on turbo. That's the one that's got the biggest range of colors, so we typically use that one the most. Okay, now we can, okay, so you have measure tools. And click on measure so you can, measure how long your survey was. You can measure anomaly size. Um, if you put stakes out where you did your survey, sometimes, GPS has got a typically about a 1.5 to 2.5 meter error. But if you put stakes out on your survey, you can go back to those and walk within that stake. Then you can go back in and you can triangulate. You can say, okay, where exactly is this one? Well, it's that far from that pin and this far from this pin. It's a nice little tool. Um, you can increase the size of this as well. So then you can clear your measures there if you want. Same thing on the raw data. You can measure. This one also has a nice feature. You can erase unwanted points. So this is helpful, like if you're outside of your survey, by your vehicle or something, getting the device warmed up, and then you walk over to your survey, you can delete that path. Or, for example, like right here, there was a gate by where I was doing a survey, and some fence here I couldn't get by, but so whenever I'd get near that, it would pick this gate up. So you can just circle an area and click on it, and it'll delete. And there's a lot of data there, so it does take a little bit of time. Or you can click on the mouse button and hold it and drag, and you can delete points that way as well. And then it'll go in and adjust this map over here. All right, then we can we'll clear that. I'm going to and you can restore your points if you mess up. And it puts your map back to normal. If you right click on either image, it takes you into a 3D view. This is useful so you can see where your path was, but it'll actually show you how strong that anomaly was right there. And so you can kind of, hey, it's saying, hey, pay attention, this is good, everything else was, little stuff. All right, if we right click on this side, this gives you some better 3D tools. These do take a little while. There's quite a bit of data to generate these 3D images. And keep in mind with magnetometers are primarily for 2D view, but there is some physics math that you can use to kind of help with depth, and this is what some of these tools will do. This is showing basically this will kind of highlight your anomalies. This is not really showing the volume or the shape in 3D, but you do get a good representation of the anomaly. You'll notice this is in a different color than your main map, and this is just showing you that this is reflectance, and not a not dependent on depth. So this is just kind of a way to visualize, how severe your anomaly is there. In a surface anomaly, a really strong surface anomaly like a metal plate will make a big deal like this because it is strong. Residual here again. This is one that'll take a lot of the background noise out, and but it does. So this sinkhole that's over there, the hole is basically that shape, and then there's about a meter down. There's a steel plate on there, so you can kind of get shape out of magnetic surveys. You just got to remember that it's more like a blob. You would never see a perfect square. It would more look like a fuzzy square, just because of the way the magnetic field works. Um, you can amplify these anomalies. You can shrink them. These are good for presentations and that kind of stuff. And then you can look at all your maps on the different views, and they can kind of help you determine whether you're going to dig or not. Uh, this one, gradient. This is a good way. You can notice there's um, a lot less anomalies on the surface there, and this is really want you to pay attention to this one. This is a pretty significant deal there. Continuation slices. This is a way that the geophysicists use to try to estimate depth. So basically, what is it's doing is it's slicing it into 5 little slices, and you can see the amplitude of the anomalies will diminish as they go down. So you can tell, like, pick a little anomaly. Let's say like these little peaks in here. You can see they're not there. So this is a surface area. A steel plate, a real prominent surface anomaly. It will continue on down through that, so do be aware of that. That doesn't necessarily mean that there's steel all the way down there. That means that this is just a very highly reflective target. We can amplify these images this way also, so you can just kind of get a feel of what's going on under the ground. But just remember that magnetometers, they're okay on depth, but it's more of a physics equation um, than seeing 3D like an X-ray. Then you have analytic response. This is another good one. This filters out a lot of anomalies, and when you see sharp things like this, so these are probably going to be all like uh, construction debris that's under that road out there or something from when they built it, like metal chunks or something. But then you can see on this big anomaly, they use this good for edge detection. Usually, like where they see a sharp spike, um, is what this map is kind of showing you, that something really quick happened here. All right, and then once you have, you can kind of adjust these images however you want, and then you can export them. It'll come up and it'll automatically make a folder, and it gives it the name of your file up there, and then you can select which ones you want. You can individually select them, or you can select all, and this will export. This can take a little bit. There's a lot of data in that. It will open it up, and it comes into, it'll make its own folder, and you can see it's starting to pop the images up. And so basically you end up with nice little images you can show. And then this has also the Google Earth overlay. This is nice. So it gives you 2 KMZ files. One is your raw path, like that image, and then you have your interpolated path, or your interpolated image. Click on that, and it automatically overlays it on Google Earth. And it's a nice feature because you can kind of see where you walked, and some things make sense, sometimes they don't. Let's see. All right. So this, for example, okay, so all those files are done exporting. All right, so here, for example, over here was where that plate was, and we can adjust the transparency to kind of see where you were. This big anomaly over here looks like it was that car, but there's a big gate there. So now you can know, okay, well, that's where that gate was. Well, let's go see what this is. So there you go. That's the new TerraXMapper, the latest. Enjoy. enjoy.